Hello everyone. In today's video, I'll be solving Codeforces Round 835 Div 4. Now, I haven't solved this problem, this contest before, so this is going to be an interesting one. I'll be explaining the problems while I solve them. So let's get started and solve as many problems as we can. I wanted to shoot this video earlier, but due to system testing, I could not do that. So here's the content. Medium number, given three distinct integers ABC, find the medium number between all of them. So it seems pretty simple. We can just take the input in an array, sort it, and print the second element, right? So 5, 2, 6, 5, yeah, seems fine. Let's code this. So template stuff, I have bits included, some input output syncing stuff, and I have LL as long. Some multiple test cases. If this is false, then solve will be called once. Otherwise, it won't be. Otherwise, it will be called the test case number of times. And rest things are pretty self-explanatory. So let's get started. No other um, predefined stuff. So we can take input as an array of size 3. That's less than 3 plus the size. We can just input the array, sort the array. So 3 is the size and simply print at 1. Compiler. This is 542 total 638. So it's 10 over 6, right? 10 over 6, yeah. So let's submit the solution. Meanwhile, second problem. In order to write a string, Atla needs to first learn all letters that are contained in the string, okay? Needs to write a message which can be represented as a string S. He asks you what is the minimum alphabet size required so that one can write this message. Okay. Alphabet size, this contains only the first letter X, Latin letters. Okay. For example, alphabet size 4 only contains A, B, C, and T. Okay, so we simply need the largest character, and we can just print that index. So basically, if I need an E, then the letter size is going to be 5, and I'll have all the elements that are present before E and E as well. So okay, so it got accepted. So what's the input format? So and the size and the string. And just need the maximum character of S. So what we can do is this cout max element of dot begin as dot end minus a plus 1. So this should be the answer. One 26 123 19 6 26 seems fine. Let's try to submit the code. So it got accepted. Nice. There are n participants in a competition. Participant I having a strength SI. Okay. Every participant wonders how much of an advantage they have over the other best participant. Okay. In other words, each participant I wants to know the difference between SI and SJ, where J is the strongest participant in the competition, not counting I. The difference can be negative. Okay. What's as inputs? Okay. Since the input goes till 10 raised to 5, we can sort this thing and we can just have the maximum and second maximum elements out. And so the best is going to be obviously the one with the maximum strength. So that will be uh, one. And to calculate the best, the one with the maximum strength, if we have to calculate the answer for that, so we'll have to subtract the second maximum out of it. So almost everyone's gonna have a negative, I suppose, except for the zeros or just the strongest guy. So all negatives, zeros are possible, and this must be the strongest guy. So in third test case, yeah, 5 is the strongest. So this should be easy to implement as well. Um, so the input format is 10 raised to 9, so integer should be good. Okay, so I've got n. Let's make a vector input n, make a vector. So we can make v1 and or just make v and v or make a and v. So we have two vectors and actually I'm gonna take the input, make a copy of this thing so that we can print the answer later. Oops. A and then sort we got begin we got. Let's reverse sort this thing so that I can. So I also need to make sure if n is at least 2, because only then I'll be able to subtract. So n is greater than 2 or equal to 2, then that works. So yeah, now I can just print the answer for n time a if is not equal to v at 0, then we can simply print, or let's just print this thing concisely. Cout I is not equal to v at 0, question mark I minus v at 0, otherwise we can print I minus v at 1, space and space. So this should be good. Let's try to see. What was the output? It says -3 2 -4 -2 -1 1 -10. So it looks good. So meanwhile, I'll try to explain the answer. So it said that we have a, so for example, we are given 1 2 3 4 as the strengths. So I need to calculate one's advantage over the best player. So that will be the one with the maximum strength. That means 4. So this will be 4 minus 1. Similarly, 4 minus 2, 4 minus 3. Now, when I have 4, that means 4 had the maximum strength and it was the best out of all. But we cannot calculate its advantage over itself. So I is not included in the best player, which means I'll have to get the maximum of this. So the answer for this is going to be 4 minus 3. Sorry, this will be 1 minus 4, 2 minus 4, similarly 3 minus 4. So that's what the question was, and it got accepted. Oops, never mind. Or in fact, let's just open it in another tab first. So you're given an array a0 to n minus 1, okay, and it has n integers. This array is called a valley if there exists exactly one subarray, so that the L and R lie in range and can be equal, okay. All numbers are equal between L and R inclusive, L equal to 0 or L minus 1 is greater than L. So, okay, this means that, um, for example, if so we need a subarray that has all the elements equal, its length can be 1. Before this, either there should be nothing in existence or it should have a larger element. Similarly, after R, there should be no element in existence or it should be larger than A of R. Now, so for example, this thing has one value. Um, Here, this is one value because it has nothing towards the left, but has this thing as a higher element. This is a value and this is also value. Then why is this not true? Okay, so this should exist exactly once. So here there are two values. So first image this value. Okay, second image. A value from 0 to 2. Yeah, that's what it was. Third image. It is not a value because two subarrays. Yeah, exactly that. So you are asked whether the given array is a value or not. Okay. So can collapse the array. I kind of run length encoding, but we don't need the frequency of arrays elements, and then we can simply keep a counter for the number of values, and if it is exactly one, then the answer will be yes. Okay, so basically if I have an array of 3 2 2 1 2 2 3 3 2 2 1 2 2 3, I want it to look like 3 2 1 2 3, and there is exactly one value, so the answer will be yes. Something like this will form. So exactly one local minima should be there, or either there should be nothing in existence. So there should be one global minima, let's say that, or one local minima. So either thing works, I suppose. Uh, let's try to code this thing. What's going? Okay, so the input standard event event size and now I need to kind of run length and code this thing, but I do not need any frequency, so I'll keep a vector for that. Now I equals 0, j equals 0, this is and I equals j, yeah, that should do. Now while j is less than n and k at I is equal j, I can do plus plus j. So basically, if I'm at 2, so move here, I will be here and j will be here. Now these are equal, j moves forward. Now they're not equal, so I need to push at I and no need to increment j. I need to push v dot push back at I, and this should be good. Now I have the collapsed array. I just need to count the number of values. So let's present values c4. So for equals 0 is less than v dot size and size. Now I'll have a left if left is equal to y is left. Okay. Let's call it L equals if I is equal to 0, that means it should be a very large number. We can make it infinity, else we can make it b at I minus 1. Similarly, r is equals to I equal I minus 1. Infinity, else v at I plus 1. Now, if so, we can do val plus equals L is greater than bi and r is also greater than bi. We can just check if values are 1. So value equal 1, then yes, else no. I have yes and no predefined. Okay, so oops. So I have yes and no predefined over here. Let's try to check if this works. Yes, double no, yes, double no. Yes, yes, no, yes, yes, okay. And see this one. So let's try to see if I collapse the array for well. I hope this is fine first of all. Just checking the precedence first, then I'll go. So yeah, it doesn't work. Let's try to print v and see if it was collapsed well. Let's copy the. So let's see. So 3, 2, 2, and 2. So yes, so it becomes 3, 2, and 2, 3. Okay, 1, 2, 3, 4, 5, 6. So 1 should have been counted as a value, right? Then we have a 1, 2, 3, 4, 3, 2, 1, 9, 7, 4, 6, 9, 10, 1000. 9, 4, 9. Okay, so the V is being built correctly. Let me check my L and R then. Value if V at I is less than L, it's V at I minus 1. Okay. If I write it this, I mean, this should have worked either ways, but let's do it this way once. I don't want to debug due to precedence stuff or anything like that. So this was the input, which is a no again. So let's try to debug this thing. I have this. I'm printing the V here. So this is y equals 0, I is less than. Okay, it should not be n minus 1, it should be val dots. So integer v dot size minus 1. Okay, that should work. It still doesn't work. Beautiful. Um, don't get it. Let's try to have a single case and then to v dot size minus 1. Then the next number is to be infinity. Yep. Let's see out L I R. Let's do this for a single test case. So I believe let's do it for this thing only. One test case and I have a 5. Okay, it said I had 5 numbers now. One test case, one number, and 5 as input. Let's just saying negative as there's too much negative. Oh, my integer overflowed. Plus 5. This should be low. Copy this thing. I do not different this. Yes, no, yes. Okay, certain things can't be helped. So the error was that my infinity was defined as a long number and I was trying to store that thing in an integer, so that overflowed. So I was not getting an infinity value, it got a 2 negative, so that never, so my left and right were never larger than my valley's value. Okay, anyway, let's move on. You are given a binary array of length n. You are allowed to perform one operation in at most once. Okay. In an operation, you can choose any element and flip it. Turn a 0 into a 1 or vice versa. Okay. What is the maximum number of inversions the array can have after performing at most one operation? So I suppose that inversions are okay. So they have given the number of inversions in an array is the number of arrays of indices I comma j such that I is less than j and ai is greater than j. So basically, if a 1 occurs before a 0 while traversing from left to right, then that's an inversion. So counting the inversions is pretty simple. That can be done in one of time. I'll just allow in a while. And so I have to tell if these are maximum. Okay. So first of all, if I have, let's suppose, a 0 1 0 1 0. Okay. So if I have to count the number of inversions, so it will be this as 1, 2, and 3. So these are the 3 inversions because the 1 over here occurs before this 0. So it is an I and J. So here I is less than J and A at I is greater than A at J. Since it's a binary array, so we can only have a 1 and 0 kind of inversion. Now, the operation can be performed at most once. So there can be one case that we invert the leftmost 0 so that this becomes a 1 and it can give us more inversions. Only that makes sense. So left 0. Second can be to flip the rightmost 1 so that we have more zeros towards the right and the existing ones cause more inversion. So right 1. And there's also a third case where we can say that no inversion. So basically no flip. So if it already has a maximum number, so 1 1 0 0, it has 4 inversions straight away. But if I try to temper, it becomes 3. Or if I try to temper this thing, sorry, this one. So yeah, so there can be a case. So for example, if I have a 1 1 0 0, if I flip the leftmost 0, so if I flip this, then the number of inversions become 3. I had a 1 1 0 0. If I flip the rightmost one, again the number of inversions reduced to 3. So these can be the three cases. Now how to calculate inversions? So it is actually pretty simple. So for example, I have 0 1 0 1 0 again. So I can have a count of ones, and whenever a 0 is encountered, I can simply do answer plus equal to that count. Let's see how does this work. So for example, at 0, the count of so here's our answer, the inversions and count of ones. So if I have the 0, then answer is still 0 and count of 1 is 0. Now I have 1 when I traverse this thing. After this, I encounter a 0. So my answer becomes 1. Then I have traverses. Now I get another 1. So count of 1 becomes 2. And I encounter another 0. So 1 plus 2, the inversions become 3. And that is the number of inversions that I showed earlier. So let's implement this real quick. So let's see the input format. This time I'll straight away use the long. I don't want that overflow thing to happen again. That was a stupidity. Okay. Oops. Let's make it 80. Okay. So it gives me an integer n, a binary array. So the index of my left 0. So I need a left 0. Okay. So that's equals -1, and index of right 1. That's also equal to -1. Now I can just simply take in the input. If LC is equal to -1. This means I have encountered my first 0. So LC equals I. So that's the index. If A at I, then I can simply do rightmost 1 is equals to I. So these are the indices. Now I can simply create a function to, so this is gonna give me the inversions. Don't need to capture anything. I just need the array and its size. So let's capture it. No, I won't capture anything. And its size. And so it's gonna have ints equals 0 and return b. So I'm gonna implement this logic in a while. Let's leave a mark here that I have to implement this. Now the answer that we have to print can be the maximum of three cases. One is that if leftmost 0 is not equals -1, that means we have a 0. In that case, we can, so we also need an answer. answer equals ends of a and n. So doing nothing, this is our first case. Second case is gonna be we flip this thing. So of LC, or let's just do it in a little fancy way. So for I in LC and O rightmost row, if I is not equals -1, then we flip the bit, so that can be done by sorting it, and we say answer is equals to max of answer and ins a comma n. Now we need to restore that bit, so flip it again. Finally print the answer. So need to implement this logic. I forgot that. Good that I left a mark over there. So then I needed the count of ones. That's 0, and inversion is already 0. Now I can just reverse it. So for y equals 0, I less than or equal to 5. Now, as we discussed, if we encounter 0, let's just do it this way. If we encounter 1, we just simply do a counter plus plus. Else, we do 1 plus equal to count. So this should do it. Okay, there's an error. Okay, it was a count 1. Let's enter count only. It should compile successfully now. It says 371.13.2. 371.13.2. Okay, it looks great. Let's submit this thing. It's the wrong answer on test case 2. That's bad. Did overflow something? So I'm just giving the right answer. So if I have a 0, I do this. Now what did I do wrong here? Take in the input. Say that if I have not got any 0 yet, then make it I. Oh, I forgot that condition. So that how bad the test case can be. If not yet 0, I forgot this thing. I mean, they passed anyway, but why am I even running these again? This is 132. Yep, that's the same thing. Dude, the samples are really weak, I suppose. It should get accepted this time. Again, a W on 2. Come on. Let's see again. I take in the input. Now, if it's not 0, it's I. Man, what am I doing? I'm submitting it straight away. I mean, I caught the mistake and I did the same mistake again. How bad can it be? Okay, so it got accepted finally. I was hoping to see all green over here, but unfortunately, that's not always the case. In fact, that's a very rare case. I could have done that in div 4, I guess, but anyway, let's continue. So F quests, okay. Um, then quests, if you complete ith, you'll gain AI coins. So the time is really less, so I'll be explaining less and just finishing this real quick. Um, if you complete ith quest, you will gain AI coins if you can complete a quest at most one per day. Okay. However, once you've completed task, you cannot do the same quest again. Okay. I'll just connect the charger once. Okay, we cannot do the same quest again. However, once you complete the quest, you can. Okay. K equal to 2 day 1, then you should. Okay, then 2 and 3 we cannot do it, and we can do it on 4. So basically, a K plus 1 delay is there. So you are given integers C and D. The maximum value of K is such that you can gain at least C coins over D days. Looks like a DP or binary search question. It's a maximum K. Like C can be really big. Okay. I think it's more of a binary search if I just can write a checker function that tells me of maybe D or something like that, and that how many maximum number of coins I can get in a particular cooldown period. Um, so if I have a cooldown period of let's in fact see a sample case. So 2, 5, 4 and a 1, 2. Okay, so 2, 5, 4 and 1, 2. It's NCD, I suppose, and these are the quest coins. Okay, now if I say that cooldown period is equals, since it's 4, okay, D is 4. And if I say that cooldown period is greater than or even equal to D, then K can be infinity. And this is one. Second thing, if K equal to 0 doesn't work, that means if I can do the maximum quest repeatedly again and again for D days, so we can say that max into D is less than C. In this case, the answer will be impossible. Otherwise, we need to print the min K. I mean the maximum value of K. Okay. Now for some K, can I tell what is the maximum number of coins that I can get in D days? So let's try to observe the pattern that uh, if let's suppose I have K equals to 4 and D is some great number. So it's like really big number. So how is gonna be the thing? So I'd like to do 2 first, then 1, then nothing here, nothing here, nothing here, then 2 again, then 1, then again nothing, nothing. Okay. So because 4 days have passed and similarly 4 days for 1 have passed here. So um, this whole block is actually equals K plus 1. And this is the ith index which is equal to 0. So next time it will be at so basically if I modulus K plus 1 lies in this range, the range of n, then I will be able to do a task on that day, otherwise I won't be able to do a task. And I should have this thing reverse sorted so that I can always do the maximum task first. So this should form the checker function. So the input is of course entity, and I'll take everything as long, no overflow thinking now. I'll have session foreign type plus n plus size of I sort a plus n greater ll. So reverse sorting it now. Have a low equals let's have those two checks first. So the check for infinity and impossible. So the first check was for infinity, that k can be greater than d. So in what case that can be true? If I sum this array till minimum of d or n and it still surpasses c. Okay. So if let's suppose n equal to 0 for n equals 0, I is less than minimum of n and d plus I and coins plus equals of I. In this case, if coins is greater than c, at least, so equal to should also work. I think it was at least, right? Yep, so equal to should also work. In that case, I can just print infinity as well. Yep, infinity and impossible. Infinity return. In what case will it be impossible? So if a at 0 and today's is still less than c, then c out impossible return. Finally, the binary search part. So low can be 0, that it's guaranteed that it can be done in 0 days, and high is so d, because if the cooldown period is like greater than d, then it would have been infinity. So low plus 1 is not equals high. We can do something. Calculate mid, that will be low plus high minus low by 2. Now if sum check, so let's have coins equal to 0 again. I need to calculate the maximum coins. Okay, so for auto less than d plus I. Now I had that mod condition, right? So mod k plus 1 should work, but when if it is an n's range, so this should work till d days. Okay, so 0 1. Okay, so the loop goes till d. If so the index, let's calculate the index. So index equals I mod k plus 1. So now if index is less than n, then we can say coins plus equals of I, actual index. Now if coins is greater than or equal to c, then low can be incremented to mid, otherwise high can be decremented to mid. Now simply c out low, and this should do our job. Okay, so k was not declared. Okay, so we have mid. To infinity impossible 1 to 12. To infinity impossible 1 to 12. Okay, this should work. Come on, get accepted. Let's go. Last problem. Let's see some green marks for motivation. Yep. Okay. So, man, this is LVG's favorite problem. The name is scary. You are given a weighted tree with n vertices. Recall that a tree is a connected graph without any cycles. Okay. A weighted tree is a tree in which each edge has a certain weight. Hmm. The tree is undirected. Okay, we can travel anywhere. Since tree bore, you decided to challenge yourself and play a game. Okay. In one move, you can move from one and travel from a node to one of its neighbors. Of course, that's what we do in a tree. Um, Start with the variable x that's initially 0. Okay, when you reach to the next node, you'll have XOR with that weight. Okay, your task is to go from vertex A to B, but you are allowed to enter B if and only if after traveling to it, the value of x becomes 0. Okay, okay. You can travel on B. Okay. Additionally, you can teleport at most once at any point in vertex. Okay, so you can teleport at any point except for B. You can tell. Yeah, okay. Answer yes if you can reach from B, otherwise no. Hmm. So, um, let's see. Basically, let's have a tree. We have B over here, B over here. Okay. So if traveling from A, so if now x becomes 0, then I'll reach B. Okay. I could also teleport to these places and get back. It gives me a feeling that we'll have to do DFS. So if I can teleport from A to a point where I can go, and so if I do a DFS from A, and store all the XOR somewhere. Okay. Obviously to the accessible paths. If I cannot reach B directly, then of course then I cannot reach these two vertices as well. I won't be able to reach these two places neither, except if I use the teleport. Okay, then I do a DFS from B itself, and if I find any common point in there, let's suppose I travel from B to this point, and this was 3, and by traveling from A to this point somewhere, I get a XOR 3, then I could have teleported. Okay. So it seems fine. What we can do is that DFS from A, store all the XORs. Then we can DFS from B, and if at any point in time, of course, we'll have to see all the accessible XORs, okay, all valid XORs. We can never exceed B if we cannot enter B. So further that will be of no use. Then if we DFS B and we find a common XOR between them, okay, so we'll always have a XOR value for a node when we reach that. In that case, the answer will be yes, otherwise it will be no. Okay, let's implement this. Okay, we'll need boolean flag equals, so we can initialize as, first thing to do ever is to initialize your global variables for test cases, otherwise they always cause trouble. Now let's take an input. We are also given, I suppose we are given A and B. Okay, so we are given NAB and then n minus 1 edges. Okay, so NAP. I'll use zero based indexing. Okay. Then n minus 1 inputs. So UV and weight. UV and weight and zero based indexing. Then we need to declare the adjacency list. It is a weighted tree, so it's just called it adjacency list. It should have a size of n, of course. And adjacency list at u dot pushback v and its weight, right? V and its weight. Similarly, v dot pushback, because it's given that it's undirected. So this is our input. Now we need to have a set. Okay, so let's also declare a set of integers st. So this is gonna store our source and store clear. Now do a DFS from A. So we need to send adjacency list. Source is gonna be A or N. So this should be enough to populate the source. So okay, so we need to have global A and B as well. Okay, now source is gonna be A for 1 and B. So void DFS. So this one's to populate all the valid source from A. And if we can reach directly from B to A, let's suppose source 0, then that case will also be catered, because while DFSing from B, if we reach A, then we can store a XOR of 0, and A initially has a XOR of 0. So that will be tackled within the implementation as well. So vector of pair of intent adjacency list. It's gonna have source equals A, XOR equals 0, and a parent equals -1. Right. Now start insert XOR. That's first thing we do. Now for ampersand the destination and its weight, and let's make source as u as well. So this should be easy to understand. Now if so, we don't explore anything after b for now. So if b is not equals to b, and we don't need to go to the parent again, so b is not equals to parent, in that case we can just say that in this case we can DFS again. Adjacency list v x will be XORed with the weight. XORed with the weight, and the parent becomes 0 now. So this should be good. So this is one of the DFSs. We need to do another DFS. So let's suppose another DFS. We'll need the adjacency list again. This time source will be B. XOR is 0 again. Parent is -1. So if let's see, sorry, so if u is not equals to b and XOR is equal to 0, that means we can directly teleport from A to a particular point and go from there to B. In that case the answer will be yes. So flag becomes true then if flag then return. Also we need to use that set. So okay, so our set already has this, so we can do it as s.count that's all. So we are not at b already, and we had this XOR in the ASDFS as well. So in that case, we can just simply say flag equals to true and return. If flag is there, that means we already have found the answer. Now I need to do the DFS. So inside u, now what can be done? So if b is not equals the parent, then we can, I suppose, do the DFS straight away. So v XOR w and u will become the parent now. Let's call the DFS to get the sensi list and see out flag yes, otherwise no. Okay, so let's run the code. Come on, and okay, too many compilation error in u. Okay, it should be at the sensi list of u. Oops. Yeah, more errors. Begin and something like since pushback. Okay, I did a typo online. Continue down. Okay, what more? No more, that's great. Let's copy the. I'm really tired now. So it says a no. And this freaks me out at this point in time. I'm tired. What did we do wrong now? So we set dot clear and DFS delete EJ. In DFS we simply insert this thing. If it is not equal to B and it's not equal to parent, then adjacency list, the source, the XOR, and the parent. So it should be populated fine. Now if U is not equal to B and st.count of XOR, then flag equals true. Okay, if flag then return. Okay, then we do the DFS for this. If is not equal to parent. Okay, we did a DFS. We are so great. This can't be held. Oops. Yes. That works. Great. So that's it for today's video. See you next time. So you can ask any of the doubts in the comment section below. I was majorly solving this time and really explaining less. So if you have any doubts, you can discuss that in comments or maybe new approaches. Do like and subscribe to this channel. See you next time. Bye.